Next, we have Dr. Leonardo Guimaraes from UFPE, another Brazilian chair of energy simulation, to give a presentation on his research.
Good morning, everyone. Well, thank you, Energy Simulation, for the opportunity to show again the results of our last year chair program. So this year we present the Thermo-Chemo-Mechanical effects at reservoir and near well scales resulting for ethylene CO₂ injection. Well, I will talk about this topic, and it will be an opportunity to talk about the project that we have with in CCS with Repsol Sinopec. It's a first year. We are in the first years of this project. And okay, this in our research programs we have the title of the chair program is underground storage and reservoir management optimization. So we have the main areas that include the ingredients of our chair is outcrop characterization. So we have a team of geologists in our group. We work with upscaling, CO₂, A2 geochemistry, digital rock analysis. We have a CT scan there that we take advantage of this. We're using digital rocks, rock mechanics, constitutive modeling. Of course, we are interested to establish stress-strain relationship for the stress path that we have in our projects. And in the reservoir management, we work with optimization, uncertainty analysis, machine learning, geomechanics, reservoir simulation and monitoring. So we try to put these ingredients in our research projects with the companies that are in our consortium. And of course, the proposal research is both for EOR and oil and gas activities, and also for underground storage like CCS and hydrogen. And let me show the projects that we have right now. Last year, for instance, so we have projects in the pre-salt challenges and also in energy transition. Last year, I presented the optimization geomechanical management. That is basically optimization of the production, taking into account geomechanical constraints. And this year, I'm going to present the CO₂ geomech project. That is a CCS project. We are going to study a candidate for pilot. And we are going to study the geomechanical, from a geomechanical perspective. And also, we have a new, this project we began in January of this year, so I'm going to show you the first results. And 2 months ago, we began another project that is the salt geomechanics project with Petrobras in Braskem, that I will take this opportunity to show you a little bit what was our experience in the past with salt geomechanics. We had the opportunity to have 2 other projects with Petrobras related to salt caverns. The first one, we evaluate the possibility of salt caverns in the pre-salt area due to injection of fluid at the reservoir. So the pre-salt is the top of the cap rock in the top of the reservoir. It was a long ago. And we had another project with Petrobras related. We had the opportunity to calibrate. This was an experiment that was performed in the Petrobras Research Center, that we calibrate models for prediction of this situation. And then we had another project on a solution mine activity in the salt domes of the pre-salt, so the possibility to have caverns in the salt domes of the pre-salt. This was about 4 years ago that we have this project. And with Vale, we had the opportunity to have the data from Taquarivassoura's mine for potassium. That is a huge mine for that we had the opportunity to calibrate models for creep in salts, considering temperature effects, the convergence of the caverns, and it's a very well monitoring. They have a very good monitoring of this mine. And we study the stability of pillars, the possibility of the integrity of the wall of the caverns, and so on. So with this background, we are going to apply this together with Petrobras and Braskem, a project that both companies are interested in salt geomechanics. And Petrobras operates in salt rock formations, and Braskem carries out a salt mine closure. So we're quite excited. This project has 2 months old, so we're just beginning the project, in fact. And today I'm going to talk about this project with Repsol Sinopec Brazil. There's numerical and experimental analysis of geomechanical effects resulting from CO₂ storage geological media. We have the objective to create the data that we don't have yet, so data from geomechanical. So we are going to do experiments, and we are going to do numerical modeling to check the integrity and to check the geomechanical effects that we can expect from this reservoir candidate. And of course, because geomechanics plays an important role in CCS project, as most of you know. So we have a workflow. And at the top of the workflow, we have the geology team that will build the initial geological model for the site. And they are also acquiring the sampling for performing experiments. In this side of in the left side, you have the experimental program that we are going to do in rock mechanics and also using CT scans, so digital rocks. So and we have partners. We have Federal University in the north of the country, UFRN, that will be exposing sandstones. That is the target that I will discuss today. With CO₂, they are specialized. They do injection tests on this, and in basalts we have reactors tests that are performed by IPR, that is an institute in the PUC, Rio Grande do Sul, is a university in the south of the country. So, and all this data from the geological model and from the experiments and digital rock, we are putting in the simulation that we are trying to build the initial models for flow, reactive transport, and geomechanics. So this is the workflow, and I will talk about a little bit on the targets, that is the sandstone depleted gas reservoir. Of course, this workflow is tailored for our infrastructures that we have there. We have a CT scan and a triaxial system. And also with the CT scan, we are going to apply digital rock analysis and to get the parameters that we don't have the ability or you don't have the time to get from the experiments. And from the, of course, you have also geomechanical codes that we develop or commercial codes that we are going to use in this project. And we had an infra upgrade very recently. We have a new CT scan and a new triaxial systems with higher confinement and temperature that we are receiving from the FINEP, that is a federal agency for supporting projects. It was last week that we received the very good news of a new triaxial systems in our lab. And it was a very hard nationwide competition that we are very happy about this. So we are going to study different scales, from the micro scale using CT scan analysis that will build models. We are going to work with digital rocks, the plug scale for experiments, basic petrophysical characterization, and also rock mechanic characterization. And and put all this information in a reservoir model. The idea is to incorporate in commercial model simulated or at least the relevant aspects for the simulation of flow and transport of CO₂ with geomechanical coupling. So we have both. We have concerns in both scales, reservoir and well, of course, and the main concerns are about storage capacity, of course, and also cap rock and reservoir rock integrity. And let me show you the first results. This is the area. The candidate is a reservoir in Parnaíba Basin. We received from our partner the initial geological model for the whole area, and we are now searching we are cutting this area, and then we are doing the specific geological model for specific sites. If you have, and you are populating the data with porosity, permeability, and so on. If you have hard questions about that, you can ask Germano. Germano is just finished his PhD on site selection for CO2, so he will be presenting a poster on this topic. And this is the top of our. This is in the top of our workflow. So if you go to the data that you are going to populate, some data we don't have right now are data related to, for instance, relative permeability and capillary pressure, that capillary curve that you don't have from the experiments, or you have a limited information for the project right now. So we are going to use reconstruction of this digital analysis to perform numerical analysis of the experiments. In this case, we did this for CO2 injection in a small sample, in a small section of the that we extracted from the plug that we scanned. So we can have all the other properties such as connected porosity, absolute permeability. It's a very nice tool to have to check with the results from the conventional tests in the lab. And of course, we have, this is a sandstone reservoir, the depleted gas reservoir with diabase and shales as cap rock, but the main cap rock is diabase. So, but we have also shales. So in this case, to get the threshold pressure in the capillary curve is a interesting data, because we are going to have pressure. CO2 will be initially will be a phase, a supercritical phase on the top of the reservoir. So it's interesting. So it's the structural trapping that most of you know, and of course we have the geomechanical aspects, the cap rock integrity related to rock fracturing and fault reactivation. And in this manner, this is the first results that we are doing experiments with different rock mechanics experiments to get the strength and stiffness of the materials that we are going to model in this first study for CCS that we are doing in this area. We have other mechanisms, solubility trapping, and we are doing numerical experiments on this. We are using both CMG and intersect codes to model this in benchmarking both codes. And we are doing already the coupling simulations for you can see here the elevation of the ground. If we inject pressure in the bottom, we can see the dissolution of CO2. So it's a multi-physical problem that we have to solve all the relevant equations. And it can be quite complicated, and we have possibility to simplify. The main question is, can we solve all these equations together, or can we separate these equations? If you go to the nature of the equations, we can see that at reservoir scales, yes, we can check the equations that in a simplified way we can check these equations. We have the equilibrium equation that the divergence of total stress. Total stress is effective stress plus pressure, and so the effective stress is related to strain, not the total. The effective stress is related to strains, and the strains are related to displacement. So at the end, we have a displacement, a very well behaved, very smooth equations for the displacement. And to have the pressure, we have to solve the parabolic equation for the diffusion equation for the pressure. That is also a very well behaved of course, equation. And we have to add, of course, the volumetric strain, because it's a mass balance. If you don't do this, we are going to lose the balance. And for the saturation, mass, And energy equation, heat equation, we have the transport equation, is a advection equation that near the wellbore, it's advection, we have domination of the advection. Again, we have to put the geomechanical term, the volumetric strain in these both equations to honor the balance. So we have two type of equations in terms of time, in terms of diffusivity. Above we have fast, and below we have slower phenomena, and we can separate them. And so we have below you have fast and smooth propagation, and that are dominant in the reservoir scale. And you have slow and sharp fronts, including the minerals that you have moving boundary problems, and that are also not relevant, but also relevant at this well scale. So in this case, you have to study the fully, maybe depends on the other conditions such as the material parameters, the boundary conditions, but sometimes you have to use a fully coupled problem to solve this problem. And of course, example are Joule-Thomson, water evaporation, salt precipitation, chemical compaction that can happen much more in the well scale. That is the region that we have higher velocities. So my time is almost run. So at the end, maybe I can decouple in the reservoir scale. In fact, with the couple, we use different simulators, geomechanical, because we have different domains as well. So we have not only the phenomena, with the domains are different for the thermal and the geomechanical problem. And below we have very rapid phenomena. And at well scale, in our project, we have two concerns. The first one is for the target that you have. We have the Joule-Thomson cooling that can, as we are dealing with a depleted reservoir, the Joule-Thomson cooling is an adiabatic cooling that accompanies the expansion of the real gas. And we are doing modeling. This is a quite simple model, but we are putting already the data that we are extracting for our experimental program. So we are doing geomechanical, rock mechanics analysis of this rock, but also thermal characterization of the rocks, thermal expansion and conductivity, for instance. And we've been working in this topic before with colleagues at Texas A&M and University of São Paulo, UNESP. We developed in our computer code the propagation of fractures due to fluid injection and thermal fracture. So it's a thermal fracture propagation that we simulate in the past with this. Is in our code. We publish many papers on this, and the idea is to do something similar to create a protocol related to the tendency of thermal fractures happen. So we are doing our first experiments in the Parnaíba Basin sandstone. We are exposing this to liquid nitrogen. Is a really recent. We are doing this sample with a hole and putting nitrogen and see what happens. It's just for sake of research, but we are interested in build a kind of protocol for this. And the other concern is related to sandstone depleted reservoirs, the chemical compaction. If you have the history of injection, we have an increase of pressure. So if you think about effective stress, we have a increase of pressure, decrease of effective stress. So we have effective stress relief. But when we stop the injection, we have a decrease of pressure close to the well, so we have a rock recompression. But during all this process, we have a continuous degradations of the rock. So we have for the geomechanical problem a stress relief and recompression, and from the geochemical point of view, we have a degradation of the rock. So, but in the recompression, it is not the same material. It's a degraded rock, and In this case, we had experience in other projects that we have. In Delft, I presented the ACE project that we are doing with Petrobras. We expose samples to ACE, and we could see how degraded will be the properties of this rock, the geomechanical properties of the rocks. We have a shrink of the yield surface, so we have a collapse of the pores due to dissolution of minerals under load when we have load applying. So we did these experiments in our lab with a soft odometer that we put the sample, apply the load, and inject acid, so we can see the decrease of volume of the sample, increase of lateral stress, and so on, and we could model very well. In this case, we are not going to use this equipment. We are going to do this using our triaxial test to capture this effect. And we just received from our partner, the UFRN, the samples that they expose to CO₂, and we try to evaluate and put in our model the behavior that we are going to model in the field. So, and Victoria, that is she's here, present a poster. She's going to KAUST very shortly to do these experiments in the same material. They have their triaxial system that can inject CO₂ under load, so it's quite similar to what we did in our soft odometer. So it's very interesting. It's part of her PhD. And okay, so conclusions. Well, if you think about geomechanical risks, and if you go to the reservoir scale, we are going to see the 4 trapping mechanisms, and the higher risk will be when the injection ends, that we have higher pressure, and the structural and less safe mechanism will dominate. And this is a very more or less well-known curve. But what we are also our 2 concerns is related to short terms in the well scale. So we have Joule-Thomson cooling, a possible Joule-Thomson cooling. We are going to check this in the next steps of these projects, and also for the long term, the rock alteration in the near bore region. We have mineral loss, chemical weakening, increase fracture susceptibility, compromise well bore stability, and so on. And okay, final conclusions. Solving multi-physics problems in large domains requires a framework to separate spatial and temporal scales. We have also to define how frequently the information between the physics will be exchanged. But it's not only to study the equations, the governing equations. We have also to take into account the material properties and the operational conditions, that in our case in the simulation is our boundary conditions. And of course, it must be addressed case by case, in a case-by-case basis. For this reason, for instance, underground storage in porous media can be very different for saline aquifers and depleted reservoirs for the perspective of geomechanics, because they have completely different stress path. So that's it. I would like to thank very much the team that we have, and all the parts of the workflow. It's 9 months of hard work that we do for these initial results. And also to Leo Soares, that is here, that is our technical focal point, that is very close to us and following this project. And of course, to our sponsors, especially Repsol Sinopec Brazil and Energi Simulation. This is a specific presentation, Repsol Sinopec Brazil, and for all the support during many years to Energi Simulation. Thank you very much.
Thank you, Dr. Guimaraes. Questions from the floor?
Thank Thank you, Professor Leonardo. It was a great presentation. So you showed some mathematical formulation for the pressure, mass balance, momentum, all the things. And the pressure equation that you showed assumed a homogeneous reservoir. Was it for the scaling purpose or the DH factor that
just just for the presentation. So just for I simplify to explain the phenomena that
I wanted to confirm it really
it could be much more complex. Yes.
Thank you. And can you comment on the mechanics, the different mechanical deformation behavior of cement and the rock? Are you doing also cement, also integrity?
No, you are not checking the cement in the well itself. You are not going to this scale. We have projects in the past with Petrobras. As we study. It was in Rio Grande do Norte, in the north part of the country, that they were injecting vapor, water vapor. It's high temperature and very aggressive, that cause a high damage from the geomechanical point of view in the cement. And we studied this. We studied the possibility of damage, create fractures in the but in this project in particular, we are not taking into account this effect. But it's important. It's an important point for, the well is a point that we can have contamination and that we can have leakage of gas. So well integrity is not related to this project specifically, but for implementation of CCS projects is absolutely important and relevant. Yes.
Thanks a lot. My last question is about the failure modeling. Up to the failure, it's already great, but then when it fails, do you nucleate cracks and do the crack?
Well, we have I don't know if I will get there. We have a technique that we call mesh fragmentation. So we include, Giovanni works with that as well, similar technique. So we include the continuous behaviors plasticity in the volume element. In the interface between the elements, we put the possibility of crack propagation. So we use damage model. So we can build a material model, use damage and plasticity, propagation, and permanent deformation, separating if you are using finite elements, it's a nice technique.
So the crack would propagate through the boundary?
Yes, we can.
Excellent.
Yes, we can do this. Yes.
Excellent. Thank you.
For instance, in this case, we have thermal contraction or thermal expansion in the volume of the rock, but we allow that in the interface of the elements, we can propagate cracks in this.
I have a question online. Mohammed Nikpour. Do you do any field tests to tune your mechanical Earth model that you have developed using the core lab data? I mean, usually we need well logs, defeats, etc., to validate and tune the mechanical Earth model for the geomechanical part.
Yes, we have data from, we asked data from ANP. ANP has the property of this data. We asked them the data from the well logs, and the research that we are doing is based on this data as well, well information. What we also predict to have, we would like to have in this project with samples for the wells. But it's very hard to get from ANP. One of the reasons is because we destroyed the sample, so we have to so what we are doing is going to the outcrop, to go to the field and get samples from outcrop. But maybe during the project we can get some samples from the wellbore as well. But yes, we are integrating our project with wellbore data. Yeah, for sure.
Okay, thank you. It's 10:30 coming up, so once again, thank you, Dr. Guimaraes.
Thank you very much.